Perhaps you have been using Unreal for a while now, and it's time to take a look at the more technical side of shading. In this video, I'm going to go over the basics of HLSL, the high-level shading language, and how you can utilize it in Unreal or be able to understand it to construct material networks to create procedural and animated textures. You'll also be able to add more complex functionality inside of your shading networks. We'll be taking a look at creating this material seen here, a material that alternates and blends to a different color or a different texture, column by column, almost how like a billboard would change its advertisement, or how lights may transition to another color on a large LCD screen. Not only are we going to create this material through nodes, we'll also take a look at how to turn those nodes into functional HLSL code as well. So let's get started. So we'll begin by creating a material. So I'll right click in the content browser, create a brand new material, and call it m_HLSL test. And we'll open it up. And by default, we get this standard shader, which has a bunch of inputs for base color, normals, roughness, and that's probably all you're going to have to use for most of your assets. Just plug in the textures that you want to connect up to your material, and that's really it. But in a lot of cases, you might need some more control, or you might be wanting to do some more animated or procedural kind of shaders or textures through these networks. And that's where HLSL will become a little bit more useful. Now, if we think about a material or a shader, it's really just a mini program. We feed it a set of inputs, and it gives us an output of how the material looks. And all that code that makes up this kind of base material here can be found under Window, Shader Code, HLSL code. And it is very complex, and we're not going to be editing this or changing this. We'll just be looking at how we can create nodes and translate those nodes into HLSL, or be able to take HLSL code and translate it back into nodes. So you could really build shaders either way, or build up your materials using nodes or using code. It doesn't really matter because they're both kind of the same thing. When we build things through nodes, it's really just scripting through more of a visual node-based system. But there are certain things that you won't be able to do through Unreal's nodes that you could do through HLSL code. So there is certain cases where you might have to choose one or the other. To create this material that we want to build, we have to think a bit about the logic of it. So if we want to build a material that goes from one color to another in these kind of columns, we have to think about a way that we can transition from that color going from right to left, and then back left to right. So an easy way we can kind of get this animation is by using a gradient, because a gradient is going to give us values from 0 to 1 in a direction, and we can sample out values from that to create a mask. So a possible way that we could do this is just create a gradient. So I'll create a linear gradient node. We'll use the U gradient, which is pretty much horizontal, whereas the V gradient would be vertical. So we'll use the U gradient, and what we can do is use a step node. And a step node will be able to isolate parts of that gradient. So if we preview the gradient from left to right, a value of 0, or black to white, value of 1. And if we step by a value of 1, it's pretty much clamping anything darker than 1 just becomes true. Anything 1 also becomes true. There's nothing kind of out of that range going up to 1. But if we set it to 0.5, well, then it cuts it in half, because it's masking away anything greater than 5, or anything greater, or 0.5. But anything greater than 0.2, same thing. Anything greater than 0.2, it'll mask away. So this is kind of being able to isolate parts of that gradient. And technically we could use this, but getting it to kind of move with that stepped kind of column size might be a little bit tricky this way. So there's a bunch of ways we could do this, but I'm going to do this a way that kind of makes it a little bit more simple, and also gives you some other approaches to be able to build other types of procedural materials. So instead of using this, we're going to try making something a little bit different. What we're going to do is we're going to create a texture coordinate node. And we'll explain why we would want to do that. If we create a texture coordinate node, so texture coordinate, we get u and v coordinates. If I preview this node by right-clicking and going to Start Preview, we can see a preview of it. And this is our UV coordinates. So it starts at 0 here, and it ends at 1 here. And there's two colors. There's red, and there's green. And the red, in this case, since it's moving up and down, that's the V coordinate. And the green is moving left to right, so it's horizontal, that's the U coordinate. So a texture coordinate node stores just UV coordinates, how a texture gets mapped onto a 3D surface. And you can use these nodes to pretty much build up rows and columns very easily. You could technically take this, and right now the values go from 0 to 1, but if we multiplied it by 10, those values would go from 0 to 10, and it would become much brighter. So if we try that, multiply this UV coordinate or texture coordinate node by 10 instead of 1. So for B, I'm entering 10 here, and we preview that, it becomes much brighter. Now, why would we want to do that? Well, what we can do now is add a kind of clamp, or a node called seal, C-E-I-L, like a sealing node. And what that will do is limit the values. And I can use this seal node, and it will round values up to the nearest whole number. So if we think about that, and maybe we visualize it, before adding a seal node, you have these values that go from 0 to 10, and they go up from 0 to 0.01, 0.02, and so on. It has all the kind of values going up to 10. But after adding a seal node, it will round everything up to the nearest whole number. So the first row will just be 1, 2, 3, 4. It'll round it up to whole numbers, giving us this more blocky look. So by doing that, by adding that seal node, that's exactly what we're going to get. This more blocky, kind of rounded up kind of rows and columns. Now the problem with this is the values are still too high. They're going from 0 to 10 instead of 0 to 1. So we'll add a divide, and we can divide it back by that original amount, 10. And maybe it's easier if I just add a node for that value of 10. So we end up with something like this. We create a texture coordinate node, we multiply it by 10, we do a sealing node to clamp it to the nearest whole number, and then we divide it by 10. And what we end up with is like a grid. And it's not going over values of 1. It's maxing out at 10. And this gives us a way to now isolate our U coordinate going from left to right. And we can do that by breaking this out. So break out those two components, the U and V. And we'll just use the U coordinate or the red coordinate. And if we view that, so if we take a look at this node, we'll be able to see the U coordinate from kind of not black because it's going to round it up to the nearest whole number. So from 1 to 10. And we now have these columns. And if we want to change those amount of columns, we just change this number here. We could make it 15, or we could make it 5 columns. Very easily we can change it. So we'll leave it at 10. And now that we have that, all we need to do is have a way of animating this. So a way of animating this is we can minus a color. We could minus some values. And the reason why that would work is if you think about it, if we minus values, so if we have something like this, and we minus kind of a gray value, that's going to remove values from the original image. So if this is like 0.1, and this is like 0.15, that row is 0.15, This row is 0.1, and we minus a color that's maybe 0.1. Well, 0.1 minus 0.1, this becomes 0, or black. And the next value here becomes a very dark value, like 0.05. And that's exactly what happens in our result here. And as this number increases, that kind of mask will expand over. And you can see an example of that here. It's a brighter value that we're minusing, and that mask expands over. So this works quite well. So we can do something like that. Now, how can we make a color that goes from dark to bright and back to dark? Well, it's actually quite easy to do something like that. We can very easily do something like that with a sine node, because a sine is just kind of a curve that goes up and down, and so on. So it goes from 0 to 1, and then 0 to 1, or whatever value you kind of want it to go up to. So we can use a sine node and connect it to a time node, which will constantly change values because time is constantly passing by. So if we preview something like that, time connected to sine, we get a color that goes from dark to white. Dark to white is really just that ramp. It's that curve going from 0 to 1, 0 to 1, and so on. It does that forever. So that's what we can use. And we can take that and we can subtract that from our u coordinate here. So subtract. And we'll subtract our sine and time node, and we'll preview this. And what do we get now? We get a ramp that's kind of more in columns, and it goes from one side to the other and then back. But the problem is it's kind of gradient. There's semi-transparent values there. Maybe we want it to be solid, like a perfectly solid mask, so we don't get this weird kind of soft transition. And a way we can solve that is by using a step node. Kind of like we used before, where we're isolating pieces of that gradient originally. But this time we're going to use the step node, and the step value for x here is going to be 0.5. That way, if it's greater than 0.5, it'll get masked away. So a step node is pretty much like a node that returns a true or false, like a solid mask or not solid mask, based on the inputted value and based on that step amount. So if it's greater or equal to that step amount of 0.5, it returns a masked value or true. And if it's lower than that value, it returns false or kind of 0. So it's a way to mask out an equal or greater value. So once we have this, we should have something that's functioning now. If we preview that, there we go. We have our kind of grid moving from right to left and left to right. And we'd be able to change this again by just changing this value here if we want more grids to be bigger, or if we want those grids to be smaller. So only 3 kind of segments now, or we could do something like 100 segments to make it super smooth, or only 2, very kind of pixelated. So again, we can change that value, it's flexible. But now what about the speed? What if we want to change the speed? Well, we could go to our sine node here and change the period value to something different as well. So we could do like 3 or 1 or maybe 10. And that can control our speed because it will fade from black to white and white to black at a different pace if we adjust that value. So maybe I'll leave it at 3. But that gives us our kind of animated procedural mask or texture. And if we want to blend this with colors or textures, we could pretty much add a lerp or a blend. So we'll do a linear interpolate, a lerp. And that just takes two values and masks it by an alpha or a mask. And that's what our material is currently producing with all these nodes, a mask. And then if we add two colors, like maybe red and blue, well, it's more of a purple, but there we go, blue. We could plug that in. And we can connect this all up to our base color or whatever else you want to connect it up to, doesn't really matter. And there we go. We have our kind of animated procedural material through nodes. Now we haven't really talked about HLSL yet. So that's going to be the next thing that we take a look at. How can we turn this network that we built here into code, which might be more simplified? And then how can we turn that code back into this network? So this is going to give us an example of how we can make that connection between Unreal nodes and high-level shading language code. So let's take a look at this network here and break it down to HLSL code. And I'm just going to make this a bit bigger here just so we can see the full network like this. And this is doing all of our heavy lifting of that masking and producing that animated kind of masked texture. So how can we simplify this into HLSL code? Well, if we look at this as kind of like a math equation, we might have to look at it a little bit kind of backwards, going from here down that way. But let's kind of evaluate what happens in what order. We have step value or step node that takes in a value and then performs a step with a value of 0.5. So if whatever's being inputted is greater or equal to 0.5, it'll mask it away. So if we think of this in kind of more of a mathematical sense, we start off with step. And then inside that step kind of node, we have our y input, and then x, which we know is 0.5. So fairly easy to understand now. What does that y connect to? It connects to a subtract. So what goes on inside the step node is really just a sine value with time plugged into it being minused with our divide with a ceiling node, a multiply node, a value of 10, and our texture coordinate. So this gets a little bit more confusing. So maybe we'll type this out and we'll be able to take a look at how we can make this into an equation fairly easily. So I'm just going to bring on over a notepad here and we'll start to kind of reverse engineer this. So we start off with step. We know the secondary value is x, which is 0.5, which we define inside of that node. So that's what we have currently. So we've kind of crossed off and finished that step node. Now what's the next thing that we have to do? Well, if we look at this, we do have a subtract. So it's going to be a minus b. So let's just type that in, a minus b. That's the next thing that we're working on. We've done that now. Now what is the b value? Well, the b value is sine with time connected to it. So let's turn that and add that into our equation and turn that into text. So sine, it'd be a sine function, and then we put t, which refers to time. Now, we'll have to connect up time to our HLSL code node, but we'll just leave it as a variable now called t for time. And it's always good to pad things with brackets, especially if you're breaking things down that are a little bit more complex, so you don't end up with any weird order of operations problems. So we finished off these two nodes now. Now what does A connect to? So A there connects to the breakout float components. we don't really have to turn that into code. That's totally fine. That's kind of like a given. We're going to be using just a single one of these values. So we actually don't really need to include that in our code. What's more important would be the divide. So this A is really the divide node, and we're dividing A by B. So I'll clean this up a bit. We'll forget all this stuff. We've already done all that. We're on this divide node. So how do we do that? So A becomes actually two things being divided. The ceiling node, we'll type ceil for now, divided by 10. Now what's inside the ceiling node? So we finished off that part. That connection's done. We have the ceiling node here. How do we break that down to code? It's the ceil value taking multiply of texture coordinate by 10. So technically it's ceil, like this. We'll put lowercase ceil. And then UV, which is going to stand for our texture coordinates or UV coordinates, multiplied, we could just use a multiply sign, by 10. And that's what we're plugging into ceil. Texture coordinates multiplied by 10. Texture coordinates multiplied by 10. And that's inside of our ceiling node. And that's really it. So we've now broken down our whole network into this kind of code. And maybe I'll pad these with brackets just to make sure it does that operation first before the division. So let's just check our brackets here. Open, open, close, close, minus open, close, and open, close. So I think that's all good. So this looks like it's all going to be good to run. And if we want to use this inside of a node in Unreal, we have to return this value. This is what we're calculating, but we have to return that. We have to export that out, or that's what the program has to return. So we have to plug it into a return as well. So now I can take all this, I can add this semicolon on the end if I want to, and I can copy all this, and I can create a custom node, which allows us to use HLSL code. And I'll open this up and I'll disconnect this from the alpha. You don't see our material updating anymore. And I'm going to put this into the code here. Return step ceil UV times 10 divided by 10 minus sine t, and step value is 0.5. So that's our full list of code. What are we outputting? Just a mask that's black and white, so we don't need a float 3 values. We don't need to store red, green, and blue 3 values. We don't need to store that. We just need to store one value, either black or white. So that's going to be fine for what we return. And then inputs, we talked about, we're using variables here for UV coordinates, UV, and T for time. So we have to add those two inputs and connect those up. So the first input is going to be maybe UV. The second input will be T for time, and that will refer directly to my code. So when I use UV in the code here, or T in the code here, it's referencing whatever's plugged in to these connections here. So now I can remove all of that node network stuff that we've done. Connect time, connect the UV coordinate, and that custom node does all that work now. And what do we end up with? There we go. We end up with like the same thing. But now it's all being done through that HLSL kind of math equation here, rather than a ton of nodes. So it may simplify it in some cases. In other cases, it may actually be easier just to use nodes in Unreal. And that really varies depending on what you're doing. But the key thing now is, since we've done that backwards, we've worked from nodes to code, it's very easy to look at this code and turn it back into nodes. You know, we start with a step, And then the Y value goes to, we take a look at this. Maybe I'll pull up the notepad, a bit easier to look at. So you start off with step. And what does the step do? We have two values being minused from each other, this and this, and we just break it down piece by piece. So the step X value is 0.5, the Y value gets two other values subtracted from each other. And we can see exactly what those two other values are doing, a ceiling node and a sine node with time. So you can start to turn HLSL code back into nodes as well in Unreal. And it may take a bit of practice. Not everything's super straightforward sometimes when looking at the code, but this should get you started and give you an idea of how to be able to work with nodes more technically, and also be able to start working with or start to take a look at HLSL code and understand what's going on. So we'll leave it there, but this allows you to create a simple node network setup with an animated procedural texture. That's fairly simple, but I'll eventually add more videos on this topic as well. So give it a try and see how it does. And if this video was helpful, make sure to like, subscribe, click the little bell button to make sure you get notifications. And if you check out the Patreon in the description, there's also, for this video, a PDF file available for any of the Patreon subscribers that kind of go over all these steps as well.